Assalamu alaikum. In today's video, we will solve complete May-June chemistry P1 step by step. So grab your paper and try each question before I reveal the answer. So let's get started. Question number 1 is that a sample of iodine is at room temperature and pressure. Which statement about the particles in the sample is correct? A. The particles are arranged in a giant lattice. That's incorrect because iodine is a simple molecular solid made up of small iodine molecules. It is not a giant, it does not have a giant lattice structure like diamond or silicon dioxide. Second, the particles have zero kinetic energy. That's also wrong because particles can never have zero kinetic energy. They are always in state of motion. The particles move randomly through the solid. In solid, the particles are arranged, they have an orderly arrangement, so they cannot move randomly. The particles vibrate at about a fixed point. Yes, that is the correct option, that in solid the particles vibrate at their fixed places. B is that element Z, the nucleon number is 31, forms an ion Z negative 3. Where is Z found in the periodic table? The group numbers are given. Now let's see that the atomic mass of Z is 31. It means that it has 15 protons. The number of protons will be 15 and number of protons and number of electrons is always the same. So the number of electrons will also be 15. And if you write the electronic configuration of this element, it would be 2, 8, 5. That makes 15 electrons. Now this 5 is the number of valence electron and it gives you the group, directly the group number. So it means that this element Z belongs to group 5, and all the elements which are present in group 5, they have an oxidation state of negative 3. Alright, so next one is that naturally occurring bromine has relative atomic mass of 80 and consists entirely of two isotopes of relative atomic mass 79 and 81. Now atomic mass of bromine is 80 and it has two isotopes, but their abundances are not given in the question. Since the abundance is not given, so we can assume that both these isotopes have equal abundances. And then if we calculate the relative atomic mass of bromine, it would be by using the formula. If we calculate it, according to the formula, it is atomic mass of the first isotope multiplied by its abundance. So we can just neglect the abundance, since we have just said that keeping the abundance is same. So we can just take there the atomic masses that are given. For the first isotope it is 79 and for the second isotope it is 81 divided by 100, and our answer would be almost 79.81, or you can round it off to 80. So we just assumed that both these isotopes are present in equal amounts, they have same abundances. So the first option is that bromine contains two isotopes in equal proportions. So that makes our first A correct. A is the correct option. Question number 4 is that element X and Y react together to form a compound. The electronic configurations of X and Y are given, and if you see the number of valence electrons in X, the number of valence electrons is 3, so that means it belongs to group number 3. And the elements which are present in group 3, they have oxidation state of positive 3. And the other element Y is, for this, the number of valence electrons is 6. So it means that Y belongs to, its number of valence electrons is 6 and it belongs to group number 6. The elements which are present in group number 6, they have an oxidation state of negative 2. Since X has an oxidation state of +3, so what does it mean? It means that it's a metal. It's a metallic ion. It's a metal. Whereas Y has an oxidation state of -2, so it makes Y a non-metal. Y is a non-metal. Now, what kind of bond is formed between a metal and a non-metal ion? Is always ionic bond. So that means that we can select from these two options, that the bond between X and Y, since one is metal, the other is non-metal, so the bond form would be an ionic bond. In the first option, they are saying that in B that two atoms each, for X, that two atoms each lose 3 electrons. If there are two atoms of X and each of these lose 3 electrons, so that means that there is a loss of 6 electrons. 6 electrons are lost. And on the other side, element Y, you have 3 atoms each receive 2 electrons. So you have 3 atoms of Y and each of these receive or they gain 2 electrons, so that makes a gain of 6 electrons. So this option is correct because there is a loss and gain of 6 electrons, since ionic bond is formed by the transfer of electrons. Now 6 electrons are being lost by the metal ion and those 6 electrons are gained by the non-metal atom. Now we move on to question number 5. Which molecule has largest number of electrons involved in covalent bonds? Covalent bonds are formed by the sharing of electrons. Each covalent bond is formed by the sharing of 2 electrons. So if we draw the structure of first ones, it is C2H4. Each covalent bond represents the sharing of 2 electrons. First of all, we can simply draw the structures. Next is carbon dioxide. This is the structure of carbon dioxide. Next one is CH3OH. There are 3 hydrogens. Then there is oxygen, and then there is a hydrogen, and then nitrogen. Now let's see, check the electrons. Each covalent bond represents 2 electrons. So there are how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So there are 12 electrons in ethene. In carbon dioxide there are 1, 2, 3, 4, 5, 6, 7 and 8 electrons. Over in methanol it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 electrons, and over here there are 1, 2, 3, 4, 5, 6 electrons. So which is the correct option? Which molecule has the largest number of electrons involved in covalent bonding? So that is our option A. Now moving on to question number 6 is that X is the arrangement of bonds around carbon in graphite. Y is the arrangement of bonds around carbon atom in diamond. Z is the arrangement of bonds around a silicon atom in silicon 4 oxide. Okay, so which arrangement of bonds are the same? In graphite, we know that there are hexagons. It has a layered structure. There are layers which are separated from each other, whereas diamond has a tetrahedral structure. So as the silica also has tetrahedral structure. Graphite has a layered structure. So that makes our option C the correct one. So which arrangements of bonds are same? It is for diamond and silicon 4 oxide. Both have a tetrahedral structure. Question number 7 is that what is the equation for the reaction between sodium carbonate and dilute nitric acid? Now sodium carbonate is alkaline, it's basic, it is an alkali. Dilute nitric acid, that's an acid, so it's an acid base reaction. The product should be salt and water. Next thing to check is the formulas. Our first reactant is sodium carbonate. Sodium has a charge of +1 and carbonate has a charge of -2. So the correct formula of sodium carbonate, if you cross multiply the charges, so it would be Na2CO3, and the product that would be formed, it would be sodium nitrate. Again, sodium has +1 charge, nitrate has -1, so positive negative will balance each other. The correct formula should be NaNO3. Now we can check, first of all we can check the correct formula for sodium carbonate. Now in these two, C option and D option, the formula of sodium carbonate is correct, but just check this one. For nitric acid the formula is wrong, so our correct option is D, because the formula of sodium carbonate is also correct. Nitric acid, the formula is correct. Sodium nitrate, the formula is correct for water and for carbon dioxide, and the equation is balanced as well. So option D is the correct option. Question number 8, which statements about relative atomic mass and relative molecular mass are correct? The mass of different isotopes does not affect the relative atomic mass. That's incorrect, because we have just calculated like we did it for bromine. Relative atomic masses do matter. The atomic masses do matter when you have to calculate the relative atomic mass. So mass of different isotopes is important. Next is that only covalent compounds have relative molecular mass. Yes, that's the correct one, because for ionic compounds we just take the relative formula mass, and for covalent compounds we take relative molecular mass. The third option is that relative atomic masses are compared to 1/12 of the mass of one atom of carbon. So this option is also correct. So that makes option C the correct option. All right, next is question number 9. Aqueous hydrogen peroxide H2O2 decomposes slowly at 25 degrees Celsius. The decomposition takes place faster when catalyst is added. A student adds small amount of catalyst to this much. What is this? This is the volume of this much. This is the concentration. Volume and concentration of hydrogen peroxide is given and collects the gas form. The volume of the gas collected is 90 cubic centimeter. Now what is this? This is the actual volume. This is the actual volume of the product, the gas that is formed. All the measurements are at room temperature and pressure. What is the percentage yield of oxygen? So we can calculate it easily. Now here, if you write the equation that was given in the question, that it is hydrogen peroxide and it decomposes to form water. The equation was given, balance equation was given, and in the equation we were also given the actual yield of oxygen gas, and it was 90 cubic centimeter. So according to the equation, 2 moles of hydrogen peroxide, it decomposes to give 1 mole of oxygen, or you can say that 1 mole of oxygen, this is equal to 24,000 cubic centimeter. All right, and in the question we were given the volume of H2O2. It was given to be 10 cubic centimeter, and if you change it to decimeter, it would be equal to 0.01 cubic decimeter. The concentration was given in the question. Concentration of H2O2, it was how much? It was 1.0 moles per decimeter cube. All right, so we just need to calculate the moles of H2O2 by using the formula that moles is equal to concentration multiplied by volume. We can calculate the moles of H2O2. Concentration is how much? It is 1.0 multiplied by volume. We have just calculated it. So what is the number of moles of H2O2? It is 0.01 moles. So if 2 moles produce 24,000 cubic centimeter of oxygen gas, then 0.01 mole will produce how much amount of gas? So we can just calculate the value of x. The value of x would be 2x will be equal to 24,000 multiplied by 0.01. So the value of x would be 24,000 multiplied by 0.01 divided by 2. And if you do the calculations, it would be 240 divided by 2, so it would be 120 cubic centimeter. All right, next we can use the formula to calculate the percentage yield. That percentage yield is equal to actual yield divided by the calculated, or you can say theoretical yield. Multiplied by 100. So our actual yield is how much? Actual yield is 90 divided by 120 multiplied by 100. So your answer would be 75%. So that makes option D the correct answer. Question number 10 is, the diagram shows the structure of the atoms of two elements X and Z. X and Z are not the atomic symbols for these elements. The elements combine to form a compound. The mass of 1 mole of the compound you have to find. Alright, so if you see the structure of this X, it has only one valence electron, so that means what does it show? It belongs to group 1. It belongs to group 1, whereas the Z has 1, 2, 3, 4, 5, 6. 6 valence electrons, so its group number is 6. And if you already know the oxidation states, what is the oxidation number of the elements which are present in group 1? It is always positive 1. And the oxidation state of all the elements which are present in group 6, it is always negative 2. So that means that X will lose 1 electron and it will gain a charge of positive 1, whereas Z can gain 2 electrons and it will gain a charge of negative 2. So if you try to write its formula, just swap their charges, you will get the formula of the compound. The formula of the compound would be X2Z. That would be the formula. Now next is that we are asked to calculate the mass of 1 mole, or you can say the molar mass or mass of 1 mole. It would be mass of 1 mole of this compound. So it would be how much? It would be equal to the atomic mass of first element is X multiplied by its subscript plus the atomic mass of Y multiplied subscript. Okay, so we can just put in the values in the formula. So it will be, what is the atomic mass? Atomic mass is the number of protons and neutrons. So it is, the atomic mass for X is how much? 7. And for this, the atomic Z, the atomic mass is 16. So you can just put the values in the formula. It is, atomic mass of X is 7, the subscript is 2 multiplied by 2 plus the atomic mass of Z is 16 but its subscript is 1. Now you can do the calculation. It would be equal to 14 plus 16, that makes 30. So our correct option is D. Question number 11. Okay, so the compound, which compound contains 45.2% nitrogen by mass? Ethene 1,2-diamine, we can just quickly find their molecular masses. So for this one, it would be, for nitrogen it is 14 plus 2. For hydrogen, for carbon it is 12 multiplied by 2 plus 14 plus 2, so that makes 60. For this one it is 14 plus 2 plus 16 plus 1, so that makes 33. Over here it is 1 plus 12 plus 16 plus 14 plus 2, so that is 45. Last one is 12 plus 3 plus 14 plus 2, so that makes 31. Now you can quickly calculate their percentages. Here we have 2 atoms of nitrogen, so it would be 28 divided by 60 multiplied by 100. The answer is 46.6%. Over here we have 14 divided by 33 multiplied by 100, so it is 42.4%. For the third one, we have 14 divided by 45 multiplied by 100. The answer is 31.1%. The last one is 14 divided by 31 multiplied by 100. The answer is 45.16%. Okay, so if you just round it off, the closest value is for D, it is 45.2. So the correct option is D in this case. Okay, question number 12. This is about copper 2 sulfate electrolyzed using copper electrodes, and the current is constant and the anode is weighed at regular time intervals. Which graph is obtained when the mass of anode is plotted against time? So this is the cell, and one is copper anode, the other one is copper cathode. For example, if this is the anode, this one is copper cathode, anode is connected to the positive terminal, cathode is connected to the negative terminal of the battery. And what happens during the process, that from the anode, copper atoms lose electrons, they change into copper ions, and then they get deposited on the copper cathode. Alright, so what happens at the anode? Anode is positively charged. Over here, copper atoms lose electrons and they dissolve into the solution, so the mass of copper decreases with time. Alright, we can also write the reaction that solid copper atoms, they lose electrons and they change into ions by the loss of 2 electrons. And at cathode, what is happening at cathode? The copper ions which are dissolved in the solution, they come at the cathode and they pick up the electrons and get deposited as copper on the cathode. Okay, so you can see that when the current is passed, the copper is lost from the anode at constant rate, so the mass of anode decreases. It must decrease uniformly with time, and it should give us a straight line with a negative slope. If you see the first graph, over here the mass decreases. Over here the mass decreases rapidly and then it slows down over here. So this means that the rate is changing, it is not constant, whereas the current that is passed is constant. So that means this is not the correct option. Over here in B, over here what is happening, that the mass of the anode is increasing. On the other hand, what happens, that the anode loses mass, it does not gain mass. So B option is also not correct. Option C is correct because the anode mass is decreasing, and it is decreasing at a constant rate because the current that is being passed is also passed at a constant rate. So option C is the correct option. Option D is also not correct. It's not correct because it starts at zero mass and then it increases. So that's impossible because anode already had some mass and it loses during the process of electrolysis. Okay, now we move on to the next question. What is question number 13? What is the chemical product of hydrogen oxygen fuel cell? So oxygen hydrogen fuel cell is used to move the space rockets and hydrogen is used as a fuel. So option B is the correct one. Hydrogen is used as a fuel which reacts with oxygen and it produces heat and electrical energy. The overall reaction for hydrogen oxygen fuel cell is that hydrogen gas reacts with oxygen gas and the product is water. This water that is produced is condensed and then it is used for drinking purposes by the astronauts. Question number 14. Question number 14 is that hydrogen can be produced by reacting methane with steam using Bond energies in the table. The enthalpy change of the reaction, what is the enthalpy change of the reaction delta H? Means we have to calculate the value of delta H for this reaction which is given above. So if you just write this reaction and show the bonds, for that we can write it over here. For the reaction It is CH4 plus 2H2O giving carbon dioxide and 4H2. So in methane, carbon forms 4 bonds with hydrogen, 4 single covalent bonds. Then we have 2 water molecules. This is first water molecule, then the second water molecule. And on the product side, we have 1 molecule of carbon dioxide and 4 molecules of hydrogen. Now from the table that is given in the paper, the bond energy of CH is 435. Over here 4 bonds are breaking, so we have to multiply it with 4, and over here 2 bonds of this water molecule, 2 bonds of the other water molecule, that makes 4 bonds. 4 bonds are breaking, so multiply the bond energy of OH bond, which is 463 given in the table. You have to multiply it with 4. The answer for this is 1740. For this the answer will be 1852. Add them both and your answer would be 3592. On the product side, the bonds that are formed are 2 CO bonds are being formed. The bond energy given in the table is 805. You have to multiply by 2 because 2 CO bonds are being made, and over here 4 hydrogen bonds are being formed. So multiply 436 with 4. The answer for this will be 1610, and for this answer is 1744. Add both of them, your answer would be 3354. Now you can calculate the value of delta H. Delta H, this is equal to the sum of the bond energies of the reactants minus the sum energies of the bond energies of the products. So it would be 3592 minus 3354. Your answer is positive 238 kilojoules per mole. So let's see which is the correct option. Our answer was 238, so that means option C is the correct answer. Okay, now we move on to question number 15. What is the best way of slowing down the reaction between magnesium and sulfuric acid? So it means that you have magnesium and the acid is sulfuric acid. We have to slow down the reaction between magnesium and sulfuric acid. How can it be done? By adding catalyst. Now catalyst speed up the reaction. Option B is diluting the acid used in the reaction. Yes, that's the correct option, because if you dilute the acid, this reduces the concentration of the acid, which again in turn lowers the frequency of successful collisions between sulfuric acid and magnesium. So a concentrated solution means more acid particles per unit volume. So again, a concentrated acid means more particles per unit volume. That results in more frequent successful collisions, and the rate of reaction would be faster. So a dilute acid, on the other hand, a dilute acid means fewer or less acid particles per unit volume. That will result in lesser successful collisions per second, and as a result what will happen? The rate of reaction will slow down. By stirring again, you increase the chances of contact between the or successful collisions between the particles, so that's wrong. Using powder instead of strip, again that's also not correct, because powder has more surface area than the strip of magnesium. Question number 16 is that the volume of the gas produced by the reaction of 100 centimeter cube of hydrochloric acid with excess of calcium carbonate is measured in two experiments. The volume of the gas are measured at room temperature pressure, and the results are shown below. In experiment 1, you can see that the volume that is formed of the gas is less, and over here in experiment number 2, the volume of the gas that is formed is more, the values are more. Which one change in the conditions to experiment 1 gives the result for experiment 2? Assume all other conditions are unchanged. A is greater volume of the acid used. Then B is a higher concentration of the acid used. Again, this is also related to the previous MCQ. Again, this, as I told you before, a higher concentration of acid, that will result in more successful collisions. Okay, so the rate of reaction would increase. Over here, if we have, it's a reaction between calcium carbonate and the acid is hydrochloric acid. Okay, so this calcium carbonate is taken in excess. Calcium carbonate is solid and it is taken as in excess. Why is it taken in excess? Because we want to use all of the acid in the reaction. So if we take concentrated acid, then the reaction will take place at a faster rate and more carbon dioxide gas will be produced. And at the end of the reaction, what will happen? That all the unreacted calcium carbonate can be easily removed. So option B is the correct option. Question number 17. Question number 17 is that hydrogen is made industrially by the reaction shown below. The reaction is given and delta H has a negative value. So what does it mean? It means that the forward reaction is exothermic, whereas the reverse reaction is endothermic. Now the question is that the statements about this industrial process are given. 1. A high pressure can be used to increase the rate of formation of hydrogen. Yes, this statement is correct, because increasing the pressure brings the gas particles together and they will collide more frequently, so the rate of reaction will increase. Number 2 is that high pressure can be used to shift the equilibrium to the right. No, that's wrong. This is wrong, because if you see this equation, we have same number of moles of gases on both the sides of the equation. Over here we have 1 plus 1, 2 moles over here, or 2 volumes of the gases on the reactant side, and 1 and 1, 2 moles of the product. Alright, so we have same volumes of reactants and products on both the sides of the equation. So when you have same number of moles, or you can say same volumes of gases on both the sides of the equation, then by changing the pressure will have no effect on the position of the equilibrium. There will be no change. There will be no change on the position of the equilibrium. It will neither shift to the right or to the left. Third is that a high temperature can be used to increase the rate of formation of hydrogen. Yes, again this is correct, because high temperature means that particles will have more kinetic energy and they will collide more often. So the rate of the reaction will increase. Fourth is that a high temperature can be used to shift the equilibrium to the right. This is again not correct. This is not correct, because the forward reaction is exothermic. See, the reaction in forward direction is exothermic, and increase in temperature, if you increase the temperature, it will favor endothermic reaction. Alright, it will favor endothermic direction, so the equilibrium will shift to the left, not to the right. So what would be our correct option? It would be, because 1 and 3 are correct, so our correct option would be B. Question number 18, that the table refers to two important industrial gaseous reactions. Number 1 is hydrogen plus nitrogen, that is Haber's process. Product is ammonia, but the catalyst written is wrong. Oxygen plus sulfur dioxide, and the product is sulfur trioxide. The catalyst is correct. So which is the correct option? Option B. All right. Question number 19. Question number 19 is that iron 2 reacts with chlorine. Which statement about the reaction is correct? Chlorine is reduced by copper 2 ions. Chlorine is the reducing agent. Iron 2 ions are reduced by chlorine, and iron 2 ions are the oxidizing agents. Again, just check the oxidation states. Over here, iron has a charge of positive 2, and it changes from positive 2 to positive 3. So which process is it? When iron changes from positive 2 to positive 3, this process is oxidation. And chlorine is 0, and from 0 it goes to negative 1. This process is reduction. Okay, so chlorine is reduced in the reaction, so it can be an oxidizing agent. Chlorine is undergoing reduction, so chlorine can be it can act as an oxidizing agent. Okay, and because it can oxidize others, and itself it can get reduced. Iron is over here, iron is getting itself, it is getting oxidized, so it can act as a reducing agent. It can reduce others, and itself it will get oxidized. So which one would be the correct option? Out of these four, the correct option would be A, because chlorine is reduced by iron ions. Question number 20. Which reagent and observation describes the test for a reducing agent? Acidified aqueous potassium manganate, color changes from colorless to purple. All right, we know that acidified aqueous KMnO4 turns from purple to colorless. Whereas aqueous potassium iodide for this, the color changes from, it turns from colorless to brown. So which one would be the correct option? It is option B, that acidified aqueous potassium manganate. For this, the color changes from purple to colorless. Alright, question number 21. The compound X is a gas. It's a gas at room temperature, and X dissolves in water to give a solution of pH 4, means acidic. It's an acidic pH, so it must contain H positive ions. Which statement about the compound is correct? A is that an aqueous solution of X will not conduct electricity. That is not correct. This is not correct because the solution is acidic and it contains some H positive ions along with some other negative ions that will also be present when there are freely moving ions present, so they do conduct electricity. Second is that atoms of metallic element are present. Now since X is a gas at room temperature, it can be any acidic gas like HCl, carbon dioxide, sulfur dioxide. All these are acidic gases and they contain only the non-metal atoms. There is no metal atom in it. Option C is metal atoms of hydrogen are present. Yes, it is because of hydrogen atom that it is acidic in nature. It is acidic with a pH of 4. B is that X is ionically bonded. Again, this is not correct because X is a gas, and if it is a gas, then it must be a small covalent molecule, whereas the ionic compounds are solids. Question number 22. Which statement about hydrochloric acid is correct? Hydrochloric acid reacts with magnesium carbonate to form 3 products. We can write the reaction. For magnesium carbonate, MgCO3 is magnesium carbonate plus hydrochloric acid. It's an acid-base reaction, neutralization reaction. The product would be salt, MgCl2 plus water. But since it's a carbonate as well, so carbon dioxide gas will be also formed. We can now balance this equation. So 3 products are formed. So option A is the correct one. Hydrochloric acid reacts with magnesium to form magnesium chloride and water. No, water is not formed. Hydrogen gas is released. When the reaction takes place between magnesium and hydrochloric acid, the salt formed is MgCl2. Along with that, hydrogen gas is formed. So this is option is not correct. When HCl is added to colorless solution of thymophthalene, it turns blue. HCl is acidic and thymophthalene is colorless in acids and it turns blue in alkalis. So this option is not correct. When hydrochloric acid is warmed with ammonium chloride, ammonia gas is formed. Again, this is also not correct because HCl and ammonia or ammonium chloride, for these there will be no reaction because ammonium chloride is itself a salt and it is a salt that is itself formed from ammonia, reaction between ammonia and hydrochloric acid. So there will be no reaction. On the other hand, if you have any ammonium salt and you react it with any alkali and you warm it, then in that case ammonia gas is formed. So this option is not correct as well. The addition of calcium hydroxide to soil reduces its acidity but also reduces the efficiency of the fertilizer. Okay, so which two equations explain this? So we know that if the soil is acidic, it is acidic due to the presence of H positive ions, and calcium hydroxide is alkaline in nature, so it will neutralize the acid and as a result water is formed. But when this calcium hydroxide reacts with fertilizers, it releases ammonia gas, due to which the nitrogen content of the soil can decrease and it does affect the, or you can say it reduces the efficiency of the fertilizers. So which reactions are correct? Calcium hydroxide does not react with carbon dioxide. It reacts with H positive ions, making the soil acidic. Then this is calcium hydroxide. This is any ammonium salt. So I told you before over here that when you have any ammonium salt and you react it with alkali, the product is ammonia. Ammonia gas is formed. See over here, it's the same reaction. Ammonia gas is formed. So this reaction is also correct. Fourth one is calcium hydroxide. They do not react with copper ions. So which option is correct? Option C, because second and the third reactions are the correct ones. Question number 24. Which anions are contained in salt that are always soluble in water? Nitrates. We all know that all the nitrates are soluble in water. Okay, question number 25. The element phosphorus is immediately below nitrogen in the periodic table. We know it's group 5. And it forms an oxide with the empirical formula P2O5. From the position of the phosphorus in the periodic table, the element is to be expected to be dash and the bonds in its oxide to be dash. Okay, so we have to select from the table. Since the phosphorus belongs to group 5, so it's a non-metal. So you can write over here that phosphorus and oxygen in their oxide we have two elements, phosphorus and oxygen. Phosphorus belongs to group 5, oxygen belongs to group 6, and both are non-metals. So they form, in the first one you will write that they are expected to be non-metals. And what is the nature of bond between the non-metal atoms? It can never be covalent, it is always ionic. So which option is the correct one? Option C. Question number 26. Question number 26 is that group 1 elements are less reactive than group 2 elements. No, this is not correct. Group 1 elements are more reactive than group 2 elements. Question number part B is, option B is, group 1 elements are stored under oil to avoid reaction with oxygen and water in the air. That is correct, because I just told you that group 1 elements are very reactive. They can react with the air in the atmosphere and they can form the oxides. That is why, due to their high reactivity, they are stored, they are kept under oil to avoid any reaction with the air. C is, group 1 elements become more reactive as the group is descended because the number of outer shell electrons increase. No, that is also not correct. D is that the melting point of group 1 elements decrease as the group is descended because there is more attraction between positive ions and the sea of electrons. Again, this is also not correct, because melting point of group 1 decreases down the group because there is less attraction between positive ions and the sea of electrons. As the size increases, the attraction decreases. Options. Question number 6 is 27 is, the table shows some properties of transition metal elements and the reasons why they have these properties. Which row shows correct property and the reason why transition elements show this property? Okay, so over here we have A. Iron has two common oxidation states, 1 and 2. That's wrong. Iron has two oxidation states, positive 2 and positive 3. Nickel can be used as a catalyst. The use of nickel raises this one is correct, but the reason is that the use of nickel raises the activation energy of the reaction. No, a catalyst decreases the activation energy, so this is also an incorrect one. C is that the reaction of aqueous sodium hydroxide with the salt of transition element can be used to identify the element, because transition metal hydroxides are often colored. Yes, this is the correct option, because many transition metal ions form characteristic colored hydroxide precipitates when they are dissolved in aqueous sodium hydroxide is added to them. These colored precipitates are used for their identification to identify the transition metal ion. These colors are used. So these colored precipitates are used for the identification, as well as whether they dissolve in aqueous sodium hydroxide or not. Both these properties are used to identify the transition metal ion. For example, copper positive 2, so it forms blue precipitates of copper hydroxide. And iron positive 2, it forms green precipitates, FeOH whole twice, and they turn brown on standing. Iron positive 3, they form reddish brown. Precipitates. Chromium positive 3, they form gray green precipitates. Which are soluble in excess sodium hydroxide. Okay. So the next one is question number 28. Which equation is correct? So for that we need to see the formulas as well as balancing. Equation A, copper plus O2. Again, the copper is not balanced. Option B is magnesium plus sulfuric acid, magnesium sulfate plus hydrogen gas is formed. Yes, this is the correct one. We can check the other two as well. Sodium plus OH, it forms sodium hydroxide. The product over here is wrong. And zinc plus nitric acid, over here the formula of zinc nitrate is wrong. Zinc has a charge of positive 2, nitrate has charge of negative 1. So the formula would be, correct formula is this. Okay. Question number 29. Metal X reacts with cold water to form a gas. Okay, so that means that metal X reacts with cold water to form a gas. It means it is, if we check X, it can be sodium. Yes, it can be sodium, because sodium is more reactive than copper, and it reacts with cold water to form a gas, hydrogen gas. Zinc displaces metal Y from the solutions of its salts. So zinc is more reactive than, if you see option Y over here, so you can say that zinc is more reactive than copper. Alright, so a metal higher in the reactivity series displaces metal which is present below it, like for example zinc plus copper sulfate. Zinc can easily displace copper from its solution and form zinc sulfate plus copper. Okay. So third is the carbonate of metal Z is insoluble. The carbonate of metal Z is insoluble. Sodium belongs to group 1 and its carbonates are soluble, so it can be copper over here. So we can say that X can be sodium, because sodium reacts vigorously with cold water and it hydrogen gases evolve when the reaction takes place. Y is copper, okay, because zinc is more reactive than copper, and it can displace copper, but zinc cannot displace magnesium, which is more reactive than copper. And our next option Z is also copper, because copper carbonate is not soluble in water. On the other hand, sodium carbonate is soluble in water. So which option matches? It is option B. Alright, so question number 30 is, which statement about alloys is correct? A, they are compounds of two or more metals. No, they are not compounds, they are mixtures. So option B is correct, that they are mixtures of metals and other metals or non-metals. This is the correct one. They conduct electricity because they have ionic bonds between metal atoms. No. They have identical physical properties through the metals they contain. No. Question number 31 is that pieces of magnesium can be attached to the steel hull of a ship to prevent rusting. This is called sacrificial protection. Which statements about sacrificial protection are correct? One is that iron atoms gain electrons from hydrated iron 3 oxide. So what happens in sacrificial protection, that magnesium, we know that magnesium is more reactive than iron, so it acts as the sacrificial anode. And when it acts like a sacrificial anode, it means that which process takes place at anode? Oxidation, the process of oxidation, which oxidation means loss of electrons. So magnesium loses 2 electrons, changes into magnesium ion, and these 2 electrons are given out. So these electrons that are released from magnesium, they flow to iron, preventing iron from oxidizing or losing electrons. Okay, so the first statement is that iron gains electrons and form hydrated iron 3 oxide. Hydrated iron 3 oxide is Fe2O3, which is called the rust, and this is formed when iron changes into iron 3 ions by losing electrons. So that does not happen, because in sacrificial protection iron is protected and it does not rust. Second option is that magnesium atoms gain electrons to form magnesium ions. No, they are losing electrons. Over here oxidation is taking place and magnesium is losing electrons, not gaining. Magnesium is oxidized, yes, because this is the correct one. So that makes option D the correct option. Okay, next is that why is carbon used in water purification? It acts as a filter to remove insoluble solids. It adds oxygen to water. It disinfects water. No. It removes taste and odors. Yes, this is the correct option. Which statement about air pollutants is correct? A is that catalytic converters in vehicles change toxic gases into non-toxic gases. Yes, this is correct, because a catalytic converter, it converts harmful gases like toxic carbon monoxide. It changes toxic carbon monoxide to non-toxic carbon dioxide. And there are some oxides of nitrogen as well. And they are changed to nitrogen molecule. Then there are unburnt hydrocarbons. That are toxic, so they are also changed to carbon dioxide and water. Now next is that flue gas desulfurization uses calcium nitrate. No, calcium nitrate is not used. Either calcium oxide or calcium carbonate is used. Instead, photosynthesis is a process that releases carbon dioxide gas. No, Photosynthesis is a process that uses or takes the plants take in carbon dioxide and they release oxygen, not carbon dioxide. Sulfur dioxide is responsible for photochemical smog. Sulfur dioxide is mainly responsible for acid rain, not for photochemical smog. Okay, question number 34. What is the structural formula of propyl methanoate? Propyl methanoate. So it is an ester. An ester has two parts in it. You can see from in its name, propyl methanoate. Alright, so A, B, C, D options are given and we need to draw the structures. Before drawing the structures, we must know that, for example, if I write a simple ester like CH3, COO, CH2, CH3. Now this is an ester and you can just divide it into three parts. All right, and when you have to write its name, then you have to write the first name. The first name is of the group that comes after oxygen, and this group comes from alcohol. The second name comes from the acid part and it ends in O8. In the end you have to write O8. Okay, now we can just draw these structures. Just see the formula. It is like CH3, COO, C double bond O and the other oxygen. Then you have CH2, then CH2 and next CH3. So here you can just divide this into two parts. Now after oxygen is the part that comes from the alcohol and the remaining part comes from the acid. All right, so the part that comes from the alcohol, see its name is written first, so its name would become propyl because it has 1, 2, 3 carbons in it, so it is propyl. And the next part that comes from carboxylic acid, which acid it is? It has 2 carbons in it, so it is ethanoic acid. And now you have to write the ending name 8, so it becomes from ethanoic it becomes ethanoate. All right, and for the B part, I told you that in an ester you can divide it into two parts, one alkyl group, then COO, and then the next alkyl group. But if you see the structure, it has, instead of COO group, it has COOC, so that's not an ester. No need to draw its structure. Next one is CH3CH2, CH3, CH2, then COO, and then CH3. Now the part that comes after oxygen comes from the alcohol. This part comes from the alcohol, this part comes from the acid, the carboxylic acid. So how are you going to write its name? The first name comes from alcohol. The alcohol is methyl, from methanol, methyl, and the acid has 3 carbons in it, so it becomes methyl propanoate. All right, then the fourth one is CH3, CH2, CH2 group in it, then O, CO, and then H. So now let's name it. The part that comes after oxygen, this is the part that comes after oxygen, and it is the one that comes from alcohol. This is the acid part. So how are you going to name it? First, the alcohol part, its name would be, it has 3 carbons in it, so its name would be propyl. And the acid is the one that has only 1 carbon, that is methanoic acid. So now it will change from methanoic to methanoate. All right. So in the question they were asking about the structure for propyl methanoate. That means our option D is the correct answer. Let's check it out. Propyl methanoate, that was our structure D. All right. So question number 35 is that which statement about ethane is correct? A is that each ethane molecule contains exactly 7 bonds, all of which are single covalent bonds. Ethane, if you draw the structure of ethane, there are 2 carbons and each carbon is making one single bond with each hydrogen. So let's count how many single covalent bonds are there. 1, 2, 3, 4, 5, 6, 7. So 7 bonds are there. That makes the option A to be correct. Ethane is a member of homologous series of alkanes, a family of unsaturated. No, alkanes are saturated hydrocarbons. The equation for complete combustion of ethane is, this is also not correct. Then the next one is that when a molecule of ethane reacts with chlorine, one molecule of hydrogen is replaced by chlorine molecule. No, again, it is not like that. One hydrogen atom gets replaced by one chlorine atom, not a chlorine molecule. So the correct answer for 35 is A. Now next one is question number 36. Isoprene is an alkene which is commonly found in plants. Which properties does isoprene have? It burns in air. Yes. Next is that it can form polymers. Yes. It is a monomer, so it can make polymers. It decolorizes aqueous bromine. Yes, that is also correct, because bromine, if you add bromine to any unsaturated hydrocarbon, it decolorizes. So which option is the correct one? Option A is the correct option. Next is question number 37. Again, there is a COO group between 2 alkyl groups, so it is an ester. The structure of ester is shown below. Which 2 compounds react to form this ester? Okay. So again, I told you, just divide it into 2 parts. After oxygen, this part comes from alcohol and this part comes from the carboxylic acid. So you just have to write which alcohol it is. It is a 3-carbon alcohol. It is propane 1-ol. And which acid it is? It has 2 carbons in it. So it is CH3COOH. Alright, which is ethanoic acid. So which option is correct? The correct option is the correct option is C, propane 1-ol and ethanoic acid. Question number 38. 25.0 cubic centimeter. This is the volume of this much concentration of sodium hydroxide. So they have given volume and concentration of sodium hydroxide is titrated with dilute sulfuric acid using a suitable indicator. 25 centimeter cube, the volume, or this is the volume of sulfuric acid is required to reach the end point. What is the concentration of, you have to find out the concentration of sulfuric acid and which indicator is used. Naturally, we will be using methyl orange, not the universal indicator. In titration, we use methyl orange. Okay, so that makes we have to select from option A and from option C. So let's solve it first of all. In the question they were given for sodium hydroxide. For sodium hydroxide, the volume that was given in the question was 25 centimeter cube and the concentration was 1.2 0.0 moles per decimeter cube. It's given in decimeter cube, so that means we have to change 25 centimeter cube into decimeter cube. So it will be equal to 0.025 just divided by 1000. Sorry, and then you will get answer in decimeter cube. Now you have to calculate the moles from the formula that concentration is moles is equal to concentration multiplied by volume. Concentration is 1.0 multiplied by volume is 0.025. So you get 0.025 moles of sodium hydroxide. Now from the equation you have, if you write the balanced equation, NaOH plus H2SO4, and it gives sodium sulfate. The formula, the charge on sulfate is -2. So the formula would be Na2SO4, sodium sulfate plus water. So neutralization reaction. Now you can balance this equation. You have to write 2 over here for balancing it. Now from the equation you can say that 2 moles of sodium hydroxide react with or they get neutralized by 1 mole of sulfuric acid. Okay, and if you have this much moles of sodium hydroxide, means 0.025 moles, then how much sulfuric acid is needed? Find the value of X, or the volume, the moles of sulfuric acid will be 2x will be equal to 0.025. X will be equal to 0.025 divided by 2. Your answer would be 0.0125 moles. So we have now calculated the moles of sulfuric acid. If we write sulfuric acid over here, in the question they just mentioned the volume of sulfuric acid, that was 25 centimeter cube. We can convert it into decimeter cube, which will be equal to 0.025 decimeter cube, and we have just calculated moles right now for sulfuric acid. Moles are equal to 0.125 moles, and we are asked to calculate the concentration. We have to calculate the concentration of sulfuric acid. Alright, so the formula for concentration is equal to moles per unit volume. Just put in the values. It is 0.0125 divided by 0.025 divided, and you will get the answer. Concentration would be 0.5 moles per decimeter cube. So answer is 0.5. Now let's check which option it is. This option is 0.5. So that makes this is wrong. So our correct option is option A. Okay, so next is question number 39. Question number 39 is that the results of paper chromatography experiment are shown. X is an aqueous solution of the salt of group 1 element. Y is an aqueous solution of a salt of a transition element. And the spots are given. Which row is correct? First is larger RF value and requires a locating agent. Alright, so X, what is X? X is a salt of group 1. So that means X would be colorless, so it would be needing a locating agent, because it's the compounds of group 1 are not colored, they are white salts. So you need their spot would not be visible, so you need a locating agent for that. And Y is an aqueous solution of transition metal. Elements are mostly colored, so they do not need a locating agent. All right, so let's see which one has more RF value. It has larger retention factor or RF value. Y has a larger RF value. It has more rate of flow with the solvent. So which option is the correct one? Option C, that Y has a larger RF value and X needs the locating agent. Question number 40. Question number 40 is that aqueous sodium hydroxide is used to identify the ions present in aqueous solutions of compounds Q and R. The results are shown below. It's a color solution. Then before addition of aqueous sodium hydroxide, after addition of few drops of sodium hydroxide, what happens that the green precipitates are formed. All right, so let's check out what are the options given to us. Chromium forms green precipitates and it is soluble in excess. Okay, and the next one is, it's a colorless solution and it gives out a gas. After the addition of sodium hydroxide, gas is given out. So that makes ammonium. All right, it can be ammonium. It can be ammonium ion because ammonia gas is produced on warming, and over here ammonium is over here, and chromium gives green color precipitates. Our option A is correct one. Copper does not give green precipitates. Iron +2 gives green precipitates which are insoluble in excess and they turn brown near the surface, but the other option is not correct. Iron +3 and ammonium ion, this option is also not correct. Okay, so that's the complete solution of May-June chemistry paper 1. I hope this video helped you understand the concepts and improve your MCQ solving skills. If you found it useful, please like the video, subscribe the channel and share it with your friends, and let me know in the comments which questions you found most challenging and which paper would you like me to solve next. Thanks for watching and I'll see you in the next chemistry lesson.